everything divided by x squared minus 8x plus 7, times x minus 7 divided by x squared minus 1. Good. So obviously we have to factor everything, we have to state restrictions and then simplify. So the only thing I can do is just factor out x. There is nothing else that I could do here. So x plus 1. The denominator has to be factored into x minus 1 and x minus 7. The numerator is x minus 7, the denominator is x plus 1, x minus 1. Let's see if this is okay.
Yes.
Very good. And now we have to state 1, 2, 3. X cannot be 7 and x cannot be plus or minus 1. There is nowhere to enter these in Pearson, but the reason I'm emphasizing this is because of what follows in math from this point on. This is very important to understand. They don't emphasize this. In a way they do, because they say, what values create an undefined situation? What is the domain of such and such? But they're not really saying, state the restriction before you simplify, which is incorrect.
I wish they had another box for those answers, because I was like, how do I answer this with that?
Correct. You cannot. Yes. Which is incorrect, but okay. So I simplify, and there is nothing else I can do. X with 1s and negative 1 and x minus 1 squared, and that's it. There is nothing else I can do here. The correct answer is this.
So I guess calculus 1 or 2, you have to know that x does not equal 7.
Yes. So that will tell you in the next step. It will tell you that these could be vertical asymptotes or holes in the graph.
I was kind of curious how you make a circle on the graph.
So very good point. So if you want to graph when you get there, not in this course, if you want to graph, for example, x minus 1 divided by x plus 1, x minus 1, you have to state those restrictions again. And because this factor goes away and the simplified form is this, when you graph, and you'll see later on, when you graph this function, this is still, because this factor is still there, there is a vertical asymptote x equals negative 1. We know that these are vertical lines. And at x equals 1, when x equals 1, the function value is 1/2. So at x equals 1, there is a hole in the graph. So the graph of this function will be like this.
Is it the u?
This is a rational function. This is f of x, 1 over x plus 1, x minus 1, and x minus 1 at the top. And of course, the graphing calculator, if students don't understand this, the graphing calculator is not going to help. So here's why. So when you put in the graphing calculator, you have to be very careful how you put it in. Parentheses around the top, x minus 1. I'm showing this. It's not a part of the class, but that's okay. So you know what to expect. I have to answer the question. So see, when I click enter, first of all, let's use the Zoom 6 standard. First of all, the calculator does not show the vertical asymptote, which is incorrect. And if you look at the graph, you'll say, oh, there is no open point. Okay, now I'm going to show you what happens here at 1. So I'm going to change the viewing window between 0 and 2. And between 0 and 1.
Oh, interesting.
So you can zoom in and it will show even better.
That's pretty cool.
Okay. So if you go back to zoom 6, nobody would know. But if you zoom in this area around 1, you will see there is a little blip in there, which is this.
So it's not necessarily a circle, but
It's an open point.
Yeah.
It's an open point. So now you know that at this point where the factor goes away, but you still have these restrictions. The function is not defined at this point and is not defined at this point. So you have to state the restrictions before. If I don't show my students why I state restrictions now, when they get here, they say, but why? I wasn't taught like this. And rightfully so, because it was incorrect what they were taught. So because the factor disappears is a whole, the factor that stays remains as a vertical asymptote. But the function is not defined at either one. So I don't want my students to get to calculus and say, oh no, why? But why? Good. Next question. Anything else? Very good questions. Anything else?
Can you do one with division?
Yes, of course.
Thank you.
So let's take a look. The next ones are with division. See if this one or this one.
That one's pretty good.
Good. So let's work on this. Everything is the same. It's just that you cannot simplify across till you change it into a product. But the rest are the same. I'm going to change the d into x because it's easier. And then x squared minus 1 divided by x plus 9 over x squared plus 10x plus 9. You can do that on your scratch paper, of course, but remember to enter with the variable that is given in the problem. So again, the same thing, x minus 1, the same thing, the difference of squares, x plus 9, the denominator x plus 9, x plus 1. So you are allowed to simplify the fraction by itself, but not across in a division, please. So don't simplify before you write not plus or minus 1 and not 9, a negative 9. So now I can simplify. And the 9 with the 9, x plus 9. So now I have the first fraction that is x plus 1. I flip now into x plus 1 over 1. And I already have stated the restriction, so the answer is x. But this is the correct answer, to be exact.
Thank you.
Thank you. Very good. Other questions? Anything else you want to look at?
How do you reset the table set?
You mean?
I mean, the window.
So you go to Zoom and you select 6. That's the standard. The standard means left negative 10, right positive 10, negative 10, 10. So the standard, very good question. The standard viewing window is negative 10 here, 10 here, negative 10, and 10. That's the standard. But if you want to change the viewing window into anything else, then you go to Window and you put in the numbers you want. So the x minimum is the leftmost x, the x maximum is the rightmost x, And this is the scale. How many ticks you want to see. What does that mean? The scale means how many ticks I want to see, either on the x-axis or the y-axis. The same thing with y. Do not bother with delta x. That's the increment. It's not important. The scale for y, yes, you can put the scale you want. The trace step is not important. The last two are not. The x-res, res, I don't even know what it is. I never used it. And then you can put the viewing window. So that's why with that function, to show you that little blip, I entered what I wanted. I wanted to see what's happening around 1 comma 0.5. So I changed from 0 to 2 on the x scale, on the x-axis, and I changed from 0 to 1 on the y-axis. And you can put the scale or the tick 0.25 if you want. And then when I clicked on graph, it showed me what I wanted. So this is the x equals 1, and I have the tick here of 0.5, so this is x equals 1 and 0.5. But when we write it on paper, we don't leave like that. We just put an open point, and that's what we know. But the graphing calculator does not put an open point. We do when we graph it on paper.
I guess on the table, if you did x1, it'll give you error.
Exactly. It has to. So if you put 1, of course, it will scream at you. If you put in -1, it will scream at you as well.
Right, because plus or minus 1.
So that's why the function is undefined there. Even if it simplifies, you're not graphing the simplified form. You're graphing the original function. Exactly. Thank you. Next question. Anything else you would like to go back to? Anything else? Other questions?
I just have more calculator questions.
Go ahead.
Like-
Yes.
Like, what's the difference between trace and graph?
Yes. Very good. So when you have a graph, let's say I graph this, and I want to trace it. When I click on trace, the calculator allows me to move the cursor. Let's say I want to determine this point. So this point is at 1.39 and the y value is 0.42, the y coordinate. So I can move left and right on the graph. That's the trace.
Like a live action.
Yes.
Okay. Cool. Thank you.
Thank you. Good. Anything else? Other questions? Anything? Good. Anything else, please?
Question.
Yes, please. Ready?
Can you go over question 39 and 8.3?
With pleasure. Just for you. Don't tell anybody else. I'm trying to find 8.3. See if it's close enough. If it isn't, you can give us yours. You said in 8.3, in practice, I'm assuming.
Yeah, it's in practice.
Okay, let's take a look at 39. See if it's close enough. This is what I'm getting.
Yeah, it's perfect.
Excellent. So we have the fourth root of 81, a to the 8th, b to the 16th. This is a nice problem. Why? Because everything is perfect. The fourth root of 81 is 3. The fourth root of a to the 8th is a squared. And the fourth root of b to the 16th, 16 divided by 4, is b to the 4th.
What if that was 12 instead?
If it's 12, then 12 divided by 4 is 3, and I have to use the absolute value. Unless they say everything is positive.
Or real numbers?
All radicands were determined using positive numbers.
But what would the question say if to get an answer of an absolute value of b to the third? We just say.
So is this okay? Can I go to a next page? Is this okay?
Yeah, that's perfect. Thank you.
Perfect. Thank you. So if I have the square root of b to the 6th, I have two possibilities. One possibility is 6 divided by 2 is 3 if I'm told that b is strictly positive or 0. But the other option is b to the 3rd with absolute value if I'm told that b is in negative infinity to infinity.
So like I guess the wordage would be for an absolute value answer.
If they don't say anything, it's this.
Okay, but if it needs to be a real number, then it would be
If they say the radicands are positive, then you don't have to worry about the absolute value. And the other option would be, let's say, the cube root of b to the 6th, which has no restrictions because it's the cube root.
Even if it was like 3, the index 3 to the 9th.
The same thing, x to the 3rd, no restrictions.
Okay.
Because the index is odd. Odd indices have no restrictions. No restrictions inside, no restrictions outside.
Okay.
The friendliest of the friendliest, like polynomials. Polynomials have no restrictions. Square roots have restrictions. Rational functions have restrictions. For example, how do I write a domain of this? Well, x cannot be -1. So the domain will be negative infinity, -1, union, -1, infinity. How do I write the domain of the square root of 2x minus 3? Well, I have to write that 2x minus 3 is greater or equal to 0, so x is greater or equal to 3/2. But how do I write the domain of the cube root of 2x minus 1? It's this. No headache. I don't have to write anything.
Okay.
It's the cube root.
That's what I was gonna ask. I was gonna ask the same thing. The cube roots are always infinity to the negative infinity to infinity.
Any odd index.
Yeah. Okay.
Yeah. Odd indices are our friends. Even indices, enemies. Just kidding, of course. So here I will write the domain as 3/2 comma infinity. Here I have the domain. I don't have to write anything. There are no restrictions. So when I enter, by the way, the cube root is what power?
Third.
Power 3 is a rational number. It cannot be a radical. So the cube root cannot be power 3, ever.
Well-
The cube root is power
1/3.
1/3. Thank you. So 2x minus 1 to power 1/3. Do not say power 3, please. And the other one, the square root. Let me give you an example with the square root. I'm going to use the same thing, 2x minus 1. Here's what happens. When I try to evaluate them, look here. And look here. Anything. -3, 100, 120, -500 or 5,000. Look, the cube root, give me anything, I'll give you a number back. But look at the square root. You cannot plug in -3 in it. You cannot plug in -5,000 in this example. You cannot plug in whatever. Because the square root has restrictions. It has restrictions under it. It cannot plug in anything. And the answer has to be positive always. But the cube root, I plug in a negative number, I get a negative number. I plug in a positive, I get a positive. I plug in a negative, I get a negative. Who cares? But the square root is a problem. Like the rational function is a problem. I cannot plug in here -1. So these are functions with problems.